Okay, good morning. I'm Laura Krueger, and I'm a grad student at the University of Colorado Boulder. I'm working with Jack Burns on the Lunar Farside Radio Telescope Array. So you've heard a little bit about that from Joe Lazio and a few others. So it operates below 100 megahertz, and we'll look into the dark ages of the universe, which is the time before the first stars ignited, before the first black holes accreted. So my work specifically is doing materials testing on the Kapton, the polyamide film that's going to be the framework material, to determine is it suitable, does it survive a lunar year. So we're very excited. We just finished construction of a second thermal vac chamber to add to our simulation laboratory. And it has all the capabilities of the previous one, but now we've added an additional lunar regolith stimulant bed of JSC1. So we're very eager to collaborate with other teams and to open up our facility to other groups wanting to conduct experiments or to test their equipment components in a lunar environment. So please visit my poster. It's number 6. And again, my name is Laura Krueger. Or just stop me as I'm wandering around today. I would love to talk with you. Thank you.
Hello, my name is Chris Yarish, and I'm an undergraduate student at the University of Colorado Boulder. I also work with Jack Burns, and our team has the 2 vacuum chambers put together to do the materials testing of Kapton. We have opened up these chambers for collaborative work with other teams looking to do testing under the simulated lunar conditions. And our team has been working with Chris McQuinn, who is with JPL's athlete team. So the athlete rover is a large rover designed for supporting human exploration of the moon or Martian surfaces. And we've been testing a joint actuator, thermal testing to see how to heat it to operating temperatures while on, say, the moon in a lunar polar conditions. And so if you have any questions or want to learn more, then stop by poster number 79. I'll be there tonight. Thank you.
Hello, good morning. My name is Jennifer Witten, and I'm a graduate student at Brown University working with Jim Head. I'm really interested in the evolution of lunar volcanism, both spatially and temporally. And so at this conference, I'm focusing on presenting work on ancient volcanic deposits southeast of the Oriental Basin in the Schiller-Shikard region. So I'm using Moon Mineralogy Mapper and Lunar Reconnaissance Orbiter data sets to study the evolution of eruption styles as well as compositions in the region. So if you want to come talk to me about that, my poster is number 55. It's bright orange and about as far away from the alcohol as you can get. If you want to venture that far, please come talk to me. I'd love to talk to you about the ancient lunar volcanism. Thank you. Hi, my name is Amy Fagan. I'm a graduate student at the University of Notre Dame, and I'm barreling towards that finish line in the next month, so yay coffee. I have been studying the geochemistry and petrology of Apollo 16 impact melts and basalts. This week I actually have a talk on some Apollo 16 basalts, which, as you know, Apollo 16 was a highland site, so any basalts that we get are fairly unusual. And the ones that I have a bit of an identity crisis. They are unlike most any other Apollo 16 basalts that we've seen. Depending on what bit of data, and I'm not going to tell you what bit of data because I want you to come to my talk. Depending on what you look at, sometimes they look like Apollo 12. Sometimes they look like Luna 16, Apollo 11, or Apollo 17. They can't decide what they want. So I want you to please come to my talk tomorrow. It's really easy to remember when it is. It's the last talk in the last session. So easy to remember. I know you'll all still be here. So come on down and I'll tell you what I think their true identity really is. Thank you.
Good morning. My name is Heidi Fukui, and I'm a graduate student at the University of California, Berkeley. I work at the Space Sciences Lab with Greg Delory, Anskita Patter, and Bob Grimm, and we are developing an electric field instrument to measure the induced electric field at the lunar surface. This is for a technique called magnetotellurics, a part of electromagnetic sounding. And if you're interested in learning more on poster number 59, I'll be there tonight. Thank you.
Hi, my name is Jamie Zlay, and I'm a grad student at the University of Colorado. I work for Mihai Hirani, and I do simulations of the lunar dusty plasma environment. The motivation from our research came from those surveyor images that we've seen so many times, and we think what they are dust clouds levitated above the surface. When you look at the scattering pattern, it looks like they're made up of 5-micron grains. These grains are really, really big. They're so big, in fact, that we're not quite sure how we can get electric fields to pull them up. In simulating these conditions, it turns out that we may have stumbled onto a really neat piece of plasma physics that could explain this cloud with grains that are over 1,000 times lighter. So if you want to come and argue with me about what this effect is, come to poster 21. It's really close to the beer, and I'll talk to you then. Thanks.
Thank you. You guys are wonderful. And thank you all for your participation.